Hello there. So the last two videos I did were mostly about 3D printer safety, both in what you can do hardware-wise, like using good components, strain relief, etc., to cut down on the risk of, causing a fire with these machines, but also on how you can configure your firmware, so the software that runs these machines, to detect when something goes wrong, and also take countermeasures to, of course, the extent that these machines can do something about, for example, the hotend overheating, MOSFET failing, or a cable burning down. But I feel like I should still go through my personal stash of 3D printers and test them. I'm not going to be testing every single one because some of them I've modded heavily, like the LoadSpot Mini, which is not running the original LoadSpot firmware, but has one on there that's running actually a prototype E3D Aero Titan extruder. So I just think that's not going to be a fair comparison, but most of these other machines are mostly stock. So I've not updated the firmware on many of these. For example, the Hobbyking Mini Fabricator, the ANET A8, I've not assembled the printer yet. That is still the firmware that, is out there in the wild the most. This is not running a community modified firmware where those checks might be enabled. This is still rocking what people get out of the box, and let's face it, that's what people are going to be using most of the time. So I'm going to be going through and be testing for min temp, max temp, and thermal runaway protection. Let's just go through those again before we start. Min temp means you have no thermistor connection, so your thermistor wire broke. Max temp is either the opposite of that, so the thermistor for the hotend shorting out, or actually the hotend or heated bed if your printer has one, getting over the maximum safe temperature. So your printer should shut off any heaters in either case. And then thermal runaway protection is basically protecting against the thermistor falling out of the hotend or just reading a wrong fixed value. And that is going to protect against the 3D printer trying to heat up the hotend, but not reading back the actual temperature increase it's causing. So those are the three safety features that these 3D printers could have enabled. I'm going to be checking each one for all three. Let's get started. This video is sponsored by Squarespace. Stick around till the end or jump right to the conclusion of this video at the 24-minute mark to learn more about them and for a discount code. So this is the machine that I want to start with. This is obviously the original Prusa i3 Mark III by Joseph Prusa. And this one I know has all these safety features enabled, but they've actually put a bit of extra effort in and are checking for a few more plausibility things. So I just want to start out by showing you what is possible with today's hardware and software. You gotta remember, this is still running like the old 8-bit Edmega board. This is not running some fancy pants 32-bit controller. This is, somewhat similar to what you'd find on any other machine. Okay, so I've set up a second camera right here that is just showing you the LCD screen, and you'll be able to see the live feedback from the screen while I mess with the electronics back here. So in the firmware configuration video, I've already shown what the Prusa Mark III is going to do, but here's a little dirty secret for you. That was actually edited down because the Mark III behaves somewhat differently to stock Marlin. It's running their own modified version of Marlin, so it doesn't quite behave exactly like another 3D printer would with a default Marlin firmware. So starting out right here, you can see it's somewhat cool down here. It has 15 degrees roughly. But because it's warm outside, I can still wear shorts and a t-shirt. This is actually quite nice. So I'm just going to start out by shorting out the thermistor, which should trigger a max temp error. So just keep an eye on that temperature. There we go, 739 degrees. And, which you actually cannot hear. Okay, it's beeping, yes. Okay, that is actually super annoying. But let me actually show you one more thing. So if we actually hone in on the hotend right here, we have the part cooling fan, which blows over your part, and your cooling fan, which blows over the hotend cooling area. So let's just keep those in view while I short out the thermistor again. There you go. So both of these are spinning up. So both the part cooling fan... One second. That's actually quite loud. So both of these fans were spinning up. Both the part cooling fan and the hotend cooling fan were spinning up to full blast. Yes, they're not really loud. This is a genuine Noctua fan, and this is also one that's running relatively slow. But the airflow still is enough to keep the hotend at temperature. So that was actually a flaw in the earlier Prusa machines that they then fixed with software, that if you were using your part cooling fan on full blast, your hotend would actually not exceed 230 degrees Celsius. So you couldn't print PLA at a super high temperature and use the part cooling fan at full blast. Now they are using that effect right now to keep that hotend at a safe temperature. So even if the MOSFET on the board would short out, or in some other way the heater cartridge would be connected straight to the input power so the printer has no way to shut that off, it can still keep the hotend at 230 degrees Celsius, which is safe for any filament and for the printer itself. So unless you have a double fault, which you're typically not engineering for, except if you're doing like automotive or military or whatever, this is so unlikely that it's going to meet every single safety specification there is for this sort of a machine. So that is pretty well done. All right, okay, let's move on to Temp, which is just straight up unplugging the thermistor. Let's see if I can get it with my fingers. There we go. So you can see that the reported temperature immediately drops to 0 degrees Celsius on the hotend, but the Mark III is not immediately triggering Temp because it's not heating, it's not putting power into the hotend. So let's try actually heating up the hotend and giving it some juice. Interesting. Temp, there we go. Okay, it triggered Temp. That was weird. I might have slightly interfered with the display cables here, I don't know. But it triggered Temp, perfect. And lastly, let's check for thermal runaway protection. Now there are these two different modes where either it monitors the temperature while heating up and then also monitors while it's at temperature that it's not dropping. And I'm only going to test for the heat up portion of that. So let's actually go in here before we unplug anything, reset this, temperatures, there we go. And set it to preheat PLA, that's 250 degrees, and let's unplug the heater cartridge. There we go. So you can still see it heating up slightly, but that is just the thermal energy inside the hotend that it just got before we unplugged the heater cartridge, and that's slowly making its way to the thermistor. So right about now, 43 degrees Celsius, yeah, that's where it's gonna stay, and it should start dropping now. There we go, 42, and it's definitely not going to rise again because it is not getting any power. So let's see when this triggers. And there we go. Well, I'm getting tools to disassemble the Ultimaker through the preheat error. And obviously this is not heated up. This is 29 degrees Celsius. All good, all protected against. Very nice. Well, let's move on. All right, next up, the Ultimaker 3. So the Ultimaker electronics are actually on the bottom right here. And that's the blocks falling out. All right, let's see. Yeah, I mean, looking at the cable that's coming out back here, this right here, this must be the extruder, but I have no idea what the pinout is. Let's see, can I actually test this at the tool head itself? Not really, because this is all encased in plastic. But yeah, it looks like I have no way of testing this except for actually digging in through the schematics. I'm hoping that is published now because this is supposed to be an open source machine. I guess if you guys know if the Ultimaker 3 has any of these checks disabled, I would assume it does not have that disabled, but you never know, you never know. Just let me know in the comments down below. But yeah, this is way harder than I expected with the Ultimaker 3. Let's move on to some machines where I actually know what I'm doing. Like the CR10. Now, the CR10, I've already shown some bits of this in the firmware configuration video, but let's actually test those things out again, Temp, Maxtemp, and the thermal runaway protection, and just see what happens. First of all, I must say that I actually do like the way that the CR10 electronics compartment is built. Like, it's very clean and very organized in there. So the only problem is that we're working on the electronics board in here, but the LCD screen is right there. So now, word of warning here, this is working on open 230 volts. Do not try this at home. I'm an engineer. I know what I'm doing. Trust me. Most of these connectors are insulated, but there are a few that are just bare open 230 volts. So just, yeah, don't use a printer that is open, that has exposed high voltage. Just close it up before you plug anything in. Okay, fans are going. Camera Creality 3D ready, nice. Okay, let's see, there's one connector that is B-Mott, Maxtemp bed immediately, cool, that's good. And then the hotend, Maxtemp immediately. There was a bit of a spark, so I'm not sure how much resistance that has, or it might just be a reflection, I'm not sure. But temperature is still displaying correctly, yes it is, 16 degrees. So let's unplug the thermistor. and we're immediately getting min temp. That is perfect. And now for the piece de resistance, let's check the thermal runaway protection screwdriver. There you go. Oh, let's actually power this off while I'm doing stuff. It doesn't need to be plugged in. Heater wire is coming out. That is just straight up disconnected. Control, temperature, nozzle, and let's just crank it up to something. Realistic 229. Perfect. Now, this machine, of course, in this case is not actually heating up. In the fail mode, this would be heating up, but the printer wouldn't be registering it. It's the exact same thing that the printer would be reading. So I'm gonna give this 2 minutes to trigger. Now, within 2 minutes, any regular hotend, and this one as well, would be at operating temperature. I don't know how long the Prusa took. It did take a while, but definitely way less than 2 minutes. So that is kind of a safe time frame. Now, we're at 1 minute 30 roughly, and it's not triggered yet. Now that means it will heat up uncontrollably if your thermistor is not connected. It will heat up as far as it gets, but I guess the redeeming factor in this case is that the hotend cooling fan is not very well constrained. So if you look in through the side, you can actually see it's not just blowing over the heatsink, which is poking out up here, but it's blowing just over the entire hotend. So this fan is not thermally controlled like on some other printers that, you know, do it in a smart way, where at 50 degrees, typically the hotend cooling fan kicks on. This is just wired straight to 12 volts. So this will limit the maximum temperature that the hotend can get up to, which I guess is better than nothing. But I mean, just to be clear, the thermal runaway feature is disabled. This will heat uncontrollably. It's just that in case the fan still runs, and it will typically be running because as long as there's power, this fan is powered, it's very unlikely that it's actually going to destroy anything, especially because this thing is mostly metal and there's nothing that could actually burn except for this nylon sleeving and cause a fire in the end. So thermal runaway protection most definitely is turned off in the CR10. Okay, next, why don't we move on to the CR10 wannabe, to the ANET E10. I mean, this is very much built exactly to look like a CR10. That's the entire purpose of this machine. You might be looking for a CR10, you see this thing, you're like, hey, that looks just like it. But let's be honest, the E10 just really doesn't live up to the CR10 at all. Yeah, so let's see how well this one does when it comes to destroying itself. Okay, there we go. Oh, look, it's the same board as A8. Let me give you guys a view of what it looks like in here. The board definitely is a lot smaller, but just the wiring job in here is a whole different league. I'll have to dig through this. Give me a second. I believe the ET connector is extruder temperature. That makes sense. Now, one thing to note as well is that the entire high voltage wiring right back here with the input and switch and everything is very crudely soldered and completely exposed. So, by the way, also they're using red and black for 230 volts, which is not to code, let's put it like that. Let's start out, where do I touch this thing? Guess here, extruder, thermistor, let's short that out. That is max temp, cool. 3D printer. Don't think they could have made that any more generic. Let's disconnect ET. Min temp immediately, that is good. And unplug end. That looks like heater wires. And actually preheated. Preheat PLA, let's just do the entire thing. 17 degrees, that should not increase because the heater is physically disconnected. Interestingly here, that both the part cooling fan and the hotend cooling fan are spinning at full speed. I don't know why. There are two fan connectors in here. I'm not sure if this is using one of these. No, so this electronics cooling fan is wired, or these two fans are wired straight to the power supply. And there are two outputs on the board, which are, looks like they have MOSFETs for them. So I'm not sure why these two are just straight up spinning non-stop. Yeah, I'm not gonna assume anything is intentional on this machine, but that might just be a unintentional safety feature in the case of the ANET E10. Same thing, I'm gonna give it 2 minutes to trigger the thermal runaway protection, and at that point we're just gonna cancel the test and move on. Yeah, okay, 2 minutes are over. This is not triggering the thermal runaway protection. Again, it's It's a safety feature that's disabled, that could be enabled, but with the fans going all the time, I don't know why these are just going all the time. They should be switched, I feel like. With these going all the time, I don't think this is actually gonna, you know, physically have the option to overheat. So another point right there. So the A8 board is actually pretty much the same that's in here. So what I'm going to be doing is I'll just be wiring in the ANIT A8 board into the case of the E10. It's all the same connections, most stuff just plugs straight in. It's just super easy to do, no fuss, and that way we can also test the A8. Power, hot end thermistor, okay. That should be it. Let's see if this actually powers up. No fans? Oh yeah, how about a power cord? Oh wait, does the A8 have a... Yeah, does the A8 have a different style of LCD? Probably does. Front face. That's okay, we're getting 15 degrees on the toolhead and on the bed, so we can just control it through the prontoface interface. So let's see, this should also spew out errors if you get any. Let's disconnect bed. Okay, and it's immediately going into temperature sensor defect. That is good. Let's try the same with the extruder. Temp sensor defect, heated bed working perfect, so that is good. And lastly, let's check for the thermal runaway by disconnecting the heater. Actually, I never needed to have the heater connected. And let's try and set a temperature of like 210. So on the board, 2 LEDs just went on, 2 red ones, one here and one there. So it is trying to heat up, but of course it's not reading back a temperature increase. I'm gonna do the same thing. I'm gonna give it 2 minutes to trigger the safety check. And if it doesn't trigger within that time, we can very safely assume that the thermal runaway protection is disabled on the A8. Which I guess we kind of know already, because the A8 is the one that likes to burn down when the thermistor falls out of the hotend, and that's the exact case that this is trying to protect against. Okay, so it's been at least 2 minutes and nothing has triggered on the A8. It's still sending back okay for just the periodic temperature checks that prontoface is sending out. So yeah, the A8 does not have that safety check. Now, whereas on the E10 you have a very metal heavy build that has very few plastic parts, the A8 has mostly plastic parts. So again, there's a lot more fuel. And I also don't know if on the A8 configuration the fans are spinning all the time, the part cooling and the hot end cooling fan, which would kind of mitigate the issue. But yeah, definitely if you're running an A8, do enable those checks. Kind of important, you know? All right, let's get this disconnected before I shock myself. Bye-bye, E10. All right, let's try this one. This is the Hobbyking Fabricator Mini. This is the original one, not the newer version 2. Built after the Tiny Boy. And yeah, it's a very basic printer actually. It does not have a part cooling fan. Like that's, I think, the biggest limitation, which I did mention in the review. It does have an E3DV6 clone, so it does have that fan on the heat sink. But otherwise, you know, it's an all plastic construction. And yeah, let's just see what this one does. So while my computer is rebooting, we can take a look at the hardware that's in here. So this is actually an MKS base V1.3. So it's a relatively large board for a really tiny printer. This is the thermistor, and then we have a output, this right here. This is the heater cartridge wires in a screw terminal. So that's pretty good, but let's check if these safety features are enabled on this one. So keep an eye on the console here, and I'm just gonna disconnect the thermistor. That should throw a min temp immediately. It does not, okay. It's showing negative 20 degrees right here. Let's see what happens if we try to heat this up. Wow. Wow, okay, nothing. There's, okay, I don't have the power connected. That's I guess a good thing. Okay. Heating failed. So that's really interesting. It is throwing the heating failed error, which means the thermal runaway protection is enabled, which is, I guess, the most complex of safety checks, but it did not throw a min temp error, which is, again, a super easy way to check for just the presence of a temperature sensor. So that is very interesting. Okay, quick reset. Let's actually do something else and short out the thermistor. I don't know how well you can see that, but it should be somewhat legible. Let's short out the thermistor input right here with just some tweezers. 892 degrees. Okay, is this a 24-volt system? I don't know, but I think I can hear the fan spinning up on the hot end, so that's temperature activated. But it's at 892 degrees and it's not doing anything. It's not disabling anything. It's not, throwing an error. So you could just as well use the printer as is, which is quite the scary oversight. Okay, so what can we make of this? Like, it has the most basic safety checks disabled, which is min temp and max temp, completely off. Like, it doesn't care at all. Yet it does have the thermal runaway protection enabled, which is kind of puzzling to me. I don't know, I believe at the time this was released, min temp and max temp were enabled by default and the thermal runaway protection was disabled, so they must have done that intentionally. I have no idea why though. Wow. Okay, so if you're using the Hobbyking Mini Fabricator 1 with the acrylic frame, definitely try and update the firmware and enable the min temp and max temp. It's just, I mean, there's literally no downside. Like, why would your hot end ever be at -20 or positive 893 degrees Celsius? Like, those are 100% unrealistic values, and the firmware should at least, throw an error and say, hey, something is wrong here. So, wow, okay, unexpected. I feel like we should at least be testing the Sigma since we skipped the Ultimaker 3, and I think the Sigma is kind of the closest thing to it. Sigma, man, this is a beast of a machine. Okay, so the electronics are in the bottom compartment here. I don't know if I'm actually going to be able to get at those, so I'm just going to try and open up the hot end shroud right here. So that's actually what is connecting the actual hot end, because these are relatively easy to swap. Okay, so that's what that looks like. There's this 4-pin connector that just plugs into this little board right at the back of the X carriage right here. Now, it only disconnects the thermistor wires, which are the 2 white ones. At the same time, it disconnects the heater cartridge, but I think I can just take out the wires from this connector and just plug in the thermistor to test the runaway protection. So let's get at that. So we do have an LCD screen, which should make this entire thing relatively easy. Oh yeah, the purple glow is back. That is so characteristic for the Sigma. Okay, 14 degrees, let's just unplug the hot end in its entirety. So this is left hot end. Remember, this is still running an 8-bit firmware, so this is running Marlin. 0 degrees. Let's see, so it's not immediately like screaming at me or anything. Let's try and heat this up. How does this work? Left thermistor not detected. Cool, it's even got a little animation going. Nice, okay. Tappy, tappy, tap. So yeah, right extruder, this one right here is perfectly working. Left one is disabled since it is not detecting a thermistor. Cool. Let's try the other use case of a thermistor short by just shorting out, bridging out the thermistor wires in the back like so. Yeah, I hear the hot end fan coming up and it's at 357 degrees Celsius. It's showing that. Let's try to heat it up. Left thermistor not detected. Okay, so it's throwing the same error, but it's max temp that's happening here. 357. If I take off my tweezers, we drop right back down to 14, so that is good. And lastly, testing for the heating. Failed for the thermal runaway. Perfect. So let's plug this back in. So the heater is disconnected right here. There you go, circle, circle, 215 degrees. Let's see how long it takes it to realize that something is wrong. Again, we're putting 2 minutes on the clock. Yeah, no, sorry. Okay, 2 minutes are over and it's still happily trying to heat. So this guy unfortunately also has thermal runaway protection disabled. Again, it's a metal shroud, it's like, but yes. It should be on. It should be on. It's not that hard. Yeah, new shirt, because this is actually day 3 of me shooting and editing this video. It was quite the beast. Okay, so what's our takeaway here? Well, I guess first of all, which shouldn't be a surprise at all, is that most machines and most manufacturers are going to use whatever the Marlin firmware, if they're using Marlin, is going to give them as a default. So that means most machines have min temp and max temp enabled, which is good, which is enabled by default, but they're going to have the thermal runaway protection disabled. To some extent, I feel like the Marlin devs should have have enabled that feature way earlier, back when it was still like unstable and in testing. I just feel like thermal runaway protection is such an essential feature to keep your machine safe that it would be better to have a few false positives where your printer stops even though nothing is wrong, than to have those cases where it's not detected and a printer actually catches on fire. What's interesting is that the Hobbyking Fabricator Mini is actually the exact reverse of that. So it has the runaway protection enabled, but max temp and min temp disabled. Now, to a certain extent that's good, but the problem here is you could just set it to 2000 degrees Celsius and it would actually try to heat up that far. It would never stop heating until it reaches that temperature, and at that point, like the heater block is going to melt off. So that's not a good way either. You really need both those features enabled. But since so many printers actually have the thermal runaway protection disabled with their original firmware, I would heavily advise you to update to at least a newer version from the manufacturer and test for that to be enabled, or use some sort of community firmware that has those features enabled, or where you can enable them yourself. Again, I did make a video on how to do that. It's super simple if you have the firmware sources already. Now, for a few printers there is that redeeming factor kind of where they have the part cooling fan and the hot end cooling fan just always enabled. So those keep the hot end from actually reaching dangerous temperatures in the first place. I'm not sure if that's intentional or if that's just lazy. Either way, it does make the printer actually a bit safer, but it's more of a crutch than a real solution to the issue of these things overheating. And maybe this is giving you a bit of perspective to why I think that Prusa is doing such a great job with their development efforts right now, because they're not just taking the stock Marlin firmware like everyone else and using it without really configuring it for the machines, but they've actually developed their firmware to be better than what you can get off the shelf right now. And because they're doing that, it is slowly being rolled back into the Marlin firmware that is more widely compatible with more machines. And I think their over temperature handling is by far the best right now. For example, that thing where it turns on the part cooling fan to full blast when it detects an over temperature situation. That's just a really smart feature, and it doesn't even require any special hardware. It's just, setting it up right and putting that development effort into it. Now, if you guys have tested your own printers by these methods and checked for min temp, max temp, and thermal runaway protection, please let me know what the results are, especially like that Ultimaker that I couldn't test because I don't have the pinout at hand. Let me know in the comments below what your results are and whether or not you're actually doing anything about it, whether you're just going like, whatever, it's gonna be fine, or whether you're actually updating your firmware to be a bit safer in that regard. Also, if you have questions on this topic, I would recommend the community forum at discuss.toms3d.org. That's the forum that I set up to be an open place for discussion, not really attached to this channel, but just being in the same spirit of encouraging a constructive discussion right over there. And before we go today, a big shout out to today's sponsors, Squarespace. Squarespace is the easy way to get yourself seen on the internet, whether you're creating an online store or creating a portfolio for your work online. Squarespace lets you create the website that is right for your needs. They will take care of the entire tech backend for you. I can actually sing a song about that. My website runs on WordPress still, and it's just a beast to maintain. So on Squarespace, there's nothing to update, install, patch ever. They will take care of that for you. And the nice thing is you can just open up your browser, pick any of their award-winning themes, add your own content, and that's it. Like, it's gonna look good on a phone, on a big desktop monitor, on anything. So go to squarespace.com/Sanadra now to get a free trial and a 10% discount on your first purchase. So as always, thank you for watching. I hope this video was helpful to you and you learned what printers typically tend to do these days. Get subscribed if you want to see more videos like it, or support this channel right over on Patreon. And also big thanks to all the patrons that are already supporting this channel and making it possible for me to run this full time. Yeah, thank you, and I'll see you in the next one.